On Earth, auroras form circles around the magnetic poles. They're beautiful, sure, but they're kind of boring because we know what's going on up there. We know it's charged particles from the sun slamming into our atmosphere at high speed. But there's something super strange about the auroras on other planets. Like Uranus, which has tilted its axis so far that its poles aren't even on the planet anymore. They're out in space. And the charged particles from the sun can get to those poles without even hitting the planet first. So you might expect that the auroras would just be, well, the same as Earth's, just shifted over to the side. But no, Uranus has a bunch of wonky aurora activity that scientists still don't understand. There's these weird spots that appear and disappear. There are giant holes in some of them, and they seem to have an electric connection with each other. So what's causing these tilted aurora beacons? Is it possible that there's something weird going on inside Uranus? Or could there be an exotic ice on its poles that's conducting electricity? This is our channel. Even though Uranus is sideways, its magnetic field is still pretty similar to Earth's. It has a magnetic north pole and a magnetic south pole, but because Uranus is so weirdly tilted, those magnetic poles don't line up with the geographic North Pole and the geographic South Pole. In fact, Uranus's magnetic North Pole is way out in space, hundreds of miles above the planet's surface, so solar wind doesn't hit the pole directly. Instead, it funnels around the planet and then crashes into the atmosphere near the equator. But that also means that if the atmosphere was somehow conducting electricity, the solar wind would eventually hit that atmosphere again up near the poles and cause auroras there. But when Voyager 2 flew by Uranus in 1986, it didn't see any auroras. The planet's atmosphere looked dead. And this was unsurprising since the Voyager probes were only designed to spot auroras at places like Earth and Jupiter, where the auroras are right above the planet's surface. To spot auroras on Uranus, we'd need to look from above or below the planet. That's why scientists were surprised in 2004 when the Hubble Space Telescope spotted auroras at Uranus's magnetic poles. The auroras weren't in the expected spots, though. They were way down here at the top and bottom of the planet. And even worse, they had this weird spiky shape. To make matters even more confusing, these auroras turned out to be super short-lived, like less than a day old. So not only were they in the wrong place, they were also in the wrong shape, and they disappeared too quickly. Now in 2013, Hubble spotted another set of auroras on Uranus. This time they were definitely in the right place. They appeared at the magnetic poles, but they still had that weird spiky shape. And once again, they faded away in less than a day. Now, Earth's auroras can also be spiky. If you look at them from the ground, they'll seem like a bunch of random lines, but from above, they'd look like a solid oval. It's only when you're between the rays of the aurora that you see the spikes. So maybe that's all this is. Maybe the auroras are actually shaped like a big oval, and we're just seeing the spikes from weird vantage points. Well, not exactly. In 2014, Hubble spotted two auroras on Uranus at the same time, one at each pole, and they both had the same spiky shape, and the distance between the tips of the spikes was exactly the same. That meant that the spikes weren't just an illusion caused by our viewing angle. They were actually real features of the auroras themselves. And besides, if these auroras were really just ovals viewed from an angle, they shouldn't fade away so fast. So what the heck is going on here? Well, scientists did eventually figure out what's causing these weirdly shaped auroras, and it turns out it's all about electric currents. All of the charged particles that make auroras are moving in electric currents, and on Earth, those currents loop neatly between the poles. But on Uranus, the electric currents take a weird path. They loop around in these twisted tubes that are connected at the top and the bottom by these thin, bright beams of light. These beams are the visible part of the aurora. And since they're connected at the top and the bottom, the shape of the beam is determined by the distance between the two auroras. And since Uranus's auroras are so widely spaced, the beams connecting them are also very long and very spiky. But how are these beams connected? Why don't they just form a complete loop? Well, It all has to do with the twist. You see, if the electric currents just formed a complete loop between the two auroras, then the magnetic field lines wouldn't twist. But the magnetic field lines do twist, so the currents can't form a full loop. They have to stay twisted until they reach the auroras. That is, when the charged particles slam into the atmosphere and release their energy in the form of light. Now, you may be thinking, great, mystery solved. But the thing is, these twisted current loops don't make sense. Here's why. As the solar wind rushes toward the planet, it'll push electric currents in one direction. But as the planet rotates, different parts of the planet pass through the solar wind. So as the auroras rotate with the planet, the new incoming solar wind should push the currents in the opposite direction. But the observations show that the currents always flow in the same direction. They never reverse. So something is preventing these currents from reversing, but we're not exactly sure what. One possibility is that there's another layer inside Uranus that we haven't discovered yet. Maybe there's a layer of electrically conducting material sandwiched between the mantle and the crust. That layer would act like a mirror for the electric currents. It would bounce them back instead of letting them flow through. But if there was such a layer, we should have detected it by now. Scientists have been studying Uranus for decades, and they would have noticed a sudden change in the planet's gravity or its rotation speed. So there probably isn't another hidden layer inside Uranus. So then maybe it's not a mirror that's bouncing the currents back, but something else. Maybe there's an exotic ice on Uranus's poles that's conducting electricity. Water ice typically only conducts electricity under extreme conditions, like near an earthquake in the depths of the ocean. But in 2017, scientists reported discovering ammonium hydride ice in the outer solar system, and this stuff conducts electricity really easily. So maybe there's enough of this exotic ice at Uranus's poles to create a current. But the electric currents we're talking about here are way stronger than anything caused by a simple ice sheet. So maybe there's some other unusual substance creating these auroras. What's happening at Uranus's poles is still a mystery, but thanks to Hubble, we've learned a lot more about it. First of all, we now know that these auroras are caused by 9 different kinds of light. Most of them are in the ultraviolet spectrum, which is invisible to our eyes, but some are in the visible spectrum. And when scientists analyzed the light, they found that all of it came from the same element, a nitrogen. Specifically, these auroras are made of nitrogen molecules that have been excited by electric currents and then release their energy in the form of light. Now, normally, this kind of thing only happens when the electric currents are really strong, like during a lightning strike. But the auroras on Uranus seem to happen with much weaker currents. And that makes sense given the name of the game here is that these auroras are really big. They stretch for thousands of miles. So while they're not caused by particularly strong currents, they're still putting out a lot of light because they're so big. We're still working on understanding the details of what's going on. But that's the basic story of the weird tilted auroras on Uranus. Thanks for watching this episode. If you want to help us explain even more mind-blowing space stuff to the whole internet, then you can join our community on a crowdfunding platform. Our supporters get access to a bunch of neat perks like blooper reels, exclusive videos, and most importantly, our private server where we can all nerd out about space stuff together. You can find our campaign link down in the description.